Okay, this is a continuation of exercise 11C examples. Here we've got an example. On the way to work, Enzo must pass through 3 sets of traffic lights, and the probability that he will stop at any particular set of lights is 3/5. Now, assuming that traffic lights are independent of each other, construct a discrete probability distribution of X, the number of traffic lights at which Enzo stops. So you're going to need a tree diagram. So we've got our first lights where it would be stop and does not stop. Then we've got our second light, stop, not stop. And our third set of lights, stop and not stop. Now, if the probability that he stops on any particular set of lights is 3/5, the probability that he does not stop is 2/5, and so on. These probabilities would continue. Okay, now there are 8 different combinations or outcomes here. So we need to see the probability that he does not stop would be this one down here, not stop 3 times. So that would be 2/5 times 2/5 times 2/5, which is 2/5 all cubed. That would be 8 over 125 because it's 2/5 times 2/5 times 2/5. The probability that he stops on all 3 lights would be 3/5 times 3/5 times 3/5, which is 27 over 125. Now we need to complete these other probabilities as well. So you can see stopping 1 time that there will be 3 different ways that he can stop 1 time. So we've got these 3. Now those 3 probabilities will be identical, and then you'll need to add them together. And stopping 2 times is one sec. The ones that I've highlighted are stopping, sorry, that one was wrong. Stopping 2 times are with the asterisks, and just stopping once is with the dots. Now the 3 with the dots will be the same, and the 3 with the asterisks will be the same, but remember you're going to have to add those 3 together. So stopping once would be 3/5 times 2/5 times 2/5. That would give our numerator 12 over 125. And so that's 12 over 125 for that, and there are 3 of those that are the same. So we would end up with 36 over 125. And stopping twice would be, with the asterisks, we'd have 3/5 times 3/5 times 2/5. That would give us 18 over 125, and we've got 3 of those, so that would be 54 over 125. Now we need to see that the sum of these probabilities is 1. And if we add all these probabilities together, we get 125 over 125, which is 1. Now we need to work out x times the probability of x. So the first one would be 0. So you can just work ahead when you're done. Just complete it. Just check your answer when you're done. 108 over 125. And 27 times 3. That would be 81 over 125, and the sum of all those is 225 over 125, which would be 9 over 5, or 1.8. So we know that that is not a whole number, so we should use the, actually we're going to use both formulas anyway in this method. Actually, these questions down here, the probability that he stops at exactly 2 sets of traffic lights, we've already done that. That was 18 over 125 times 3, which was, that was 54 over 125. Now, no more than 2 sets of traffic lights. So we could have 0, 1, or 2 sets of traffic lights. Instead of adding those 3 probabilities together, it would be easier to do the total, which is 1 minus probability of stopping at 3, which is 1 minus 27 over 125, which is 98 over 125. Now the probability of stopping at least 2 sets of traffic lights, that's just the probability of 2 or 3. which would be just adding those two there. So 54 plus 27 over 125, which is 81 over 125. And fewer than two sets of traffic lights will be probability of stopping at 0 or 1, which is 8 plus 36. We've got 44 over 125. Okay, now you should be able to keep working with these. So just going through the solutions here, the expected number of traffic lights at which Enzo will stop, that is the sum, expected number is the sum of the x times px values. So expected value is the sum of the x times px values, which is 9 over 5 or 1.8. So it's expected to stop at 1.8 traffic lights. Notice that that is not a whole number. So given that the variance is the sum of x minus mu squared times probability of x, it's saying to add another 2 rows to the probability table to calculate the variance. So remember, the variance is the expected value of x minus mu squared. So we're just going to do that. Okay. Remember, this will be, the results won't be very nice for this method because the mean or the expected value is not a whole number. So you're going to, you won't be able to do them in your head. You're going to have to use your calculator to do it. So that's asking for the x minus mu squared and the x minus mu squared times the probability of x. Just give you a few minutes to do that. Doing x minus mu squared, we get these values and then multiplying those by the probability. So 1 over 25 times 8 over 125, etc. And doing that for all the x minus mu squareds times the probability of x. And adding them up and totaling, we get 18 over 25. So therefore, this is the expected value of the expected number of times. Sorry, no, this is the variance. Sorry, this is the variance. The variance is 18 over 25. So variance is 18 over 25. That's what we got for the variance in x. Okay, now remember the alternative formula is to do x squared px minus mu squared. So just going to add another, you can add another row to the table. I know that there's not really enough room there, and then work out your variance that way. Remember, this is the preferred method if your mean or if your expected value is not a whole number. So it's x squared times px. So we need to square this and multiply by px. The first one would be 0. The second is just 36 over 125. The next one, that would be 216 over 125. The next one would be 243 over 125. And then if we add those all together, we get 495 over 125. Now that can be simplified, but I'll do it further down. So we've got 495 over 125 is the sum of x squared px. So therefore, this is our formula. So that is 495 over 125 minus the expected value, or mu squared. Now expected value is 9 over 5, or mu is 9 over 5 squared. And we get 18 over 25, which is the same result as there. So much easier result. So the variance in x is 18 over 25. So we get the same with both methods. And given that the standard deviation is the square root of the variance, calculate standard deviation. Well, the standard deviation, the symbol is sigma, which is the square root of 18 over 25. Well, the square root of, you could just get a decimal answer for that if you wanted. We don't really need an exact answer there. And putting that on your calculator, you would get 0.848, just giving a few decimal places. Okay. Just these other two questions here from exercise 11C. The random variable x records the number on a spinner with sectors of equal size marked 1, 2, and 3. So if a spinner has sectors of equal size marked 1, 2, and 3, then the probability of each outcome would be the same. So the probability of a 1 is the same as the probability of a 2, which equals the probability of a 3, which is a third. So the probability of 1 will equal the probability of getting a 2, which will equal the probability of getting a 3, which is 1/3. So what sort of distribution is this? It is a uniform probability distribution. It's because the probability of each outcome is the same. Okay, so if I fill in my probabilities here, 1/3, 1/3, and 1/3, the sum of all my probabilities is 1. And if I look at x times the probability of x, I get a third, 2/3, and 3/3, which is 6/3, or 2. So therefore, the expected value here is 2. Expected value of x is 2, and the variance. Now, because we've got whole numbers, you could use either method. We can do x squared px, or you could use x minus mu squared. If you do x minus mu squared, then you'll have to do, let's use that method. We'll go x minus mu squared, or you could just do x squared px, it doesn't matter. Then we've got x minus mu all squared times the probability of x. So x minus mu, so 1 minus 2 is -1, square that and you get 1. 2 minus 2 is 0, 0 squared is 0. 3 minus 2 is 1, 1 squared is 1. You don't need the sum of those. Now, x minus mu squared times the probability of x, so I'm multiplying these two, and I would get a third, I would get 0, and I would get a third, and adding those up, that gives me my variance straight away. So this one here is my variance. Okay, variance is the sum of x minus mu squared times the probability of x. So if I use this method here, I get 2/3. If you want to use the alternative method, which is to calculate x squared px, you could do that. I'll do that one in red. So the formula for that one is the sum of the x squared px's minus mu squared. So x squared px is this squared times that. So you would get a third. 2 squared, which is 4 times a third, is 4 on 3. And 3 squared is 9 times a third, which is 9 on 3. Adding those together, you've got 5, you've got 14 on 3. So doing it this alternative method, you would get 14/3 minus mu squared is minus 2 squared. So it's 14/3 minus 4. Now that is 2 and 2/3, no, sorry, that's 4 and 2/3 minus 4, which is 2/3. So again, getting the same result, just using that other method, okay? Now the last question. Okay, so it says for some values of k, a random variable x with the values 1, 2, 3, 4 is defined by this. Now you haven't seen a question like this. It's defined by probability that x takes on that value of x there in the table equals kx, for x is 1, 2, 3, and 4. So when x is 1, the probability is, when x is 1, you get 1k. When x is 2, the probability is 2k. When x is 3, you get that the probability is 3k. And when x is 4, you get the probability is 4k. Now, so you add these together, 1k plus 2k plus 3k plus, sorry, that's a 4, plus 4k is 10k. Now, thinking back to our other exercises, if we add them up, we get 10k. But we know that the sum of all probabilities in a probability distribution is 1. So therefore 10k is 1. So therefore k is 1/10. So now that we know that k is 1/10, we can write the actual probabilities here on the next row. So 1 times 1/10 is 1/10, 2 times 1/10 is 2/10, 3 times 1/10 is 3/10, and 4 times 1/10 is 4/10. If you add those all up, you get 10/10 or 1. So now you can work out the rest, the expected value and the standard deviation. Okay? And just checking your answers. Once you've done that, you've got 1/10, 2 times 2/10 is 4/10, 3 times 3/10, 9/10, 4 times 4/10 is 16/10, 30 over 10 is your sum, so you get 3. So therefore your expected value is 3. Now, you can use either method. You can use squaring, either method for your variance. And then for your standard deviation, you need to square root the variance. Okay, so let's go with, we'll just do the x squared px method. Okay, this time. So x squared px is 1 squared times 1/10 is 1/10. 2 squared times, so that's 4 times 2/10 is 8/10. 9, so 3 squared, 9 times 3/10 is 27 over 10. And 4 squared, that's 16 times 4/10, that's 64/10. And then adding that up, we get 100 over 10, which is 10. So x squared px is 10. So therefore, the variance of x is the expected value of x squared, or it's the sum. You can write it like that, minus mu squared, or you could write it as the sum of x squared times the probability of x minus mu squared. So this is your sum. This is your e of x squared. Just be careful. So it's an e of x squared, expected value of x squared, is the same as the sum of the x squared px's. So that is 10 minus mu squared, this is mu, or my expected value of x. So it's 10 minus 3 squared, which is 1. So it's 10 minus 9, which is 1. Now you could have worked it out the other way with x minus mu squared times the probability of x, and you should get the same answer. Alternative method, now I've done this in one line. I've done x minus mu squared and times it by the probability of x. So just here, for example, 1 minus 3 is -2 squared is 4 times the probability of x. 4 times 1/10 is 4/10. 2 for this one, 2 minus 3 is -1. If you square that, you get 1 times the probability of x is times 2/10 is 2/10. 3 minus 3 is 0. 0 squared is 0 times 3/10 is 0. And 4 minus 3 is 1. 1 squared times 4/10 is 4/10. Adding those up, this is the variance in x. So you've got your two different methods there. You can use either method, and so therefore your standard deviation is the square root of the variance. Okay, it's got symbol sigma. It's the square root of your variance of x, which is the square root of 1, which is 1. Okay.